Today we are looking at inequalities.
Chill out.
We're doing something that's similar to what we've been working on. All of the statements, math statements that we've been working with have had equal sign in them. And today we're going to take out the equal sign and we're going to put in inequality signs. So let's just review. Inequalities. There's 4 symbols here, and they're called inequality symbols. Inequality symbols are used to compare two numbers. For example, this means that 8 is more than 5, and this means that 1 is less than 4. The inequality always points to the lesser of the two numbers, and the lesser of the two numbers is the number farthest to the left on the number line. So when you guys worked with inequalities, you think of this as a what? Alligator, and the alligator always eats the bigger one.
I learned that it was a really big fish.
Okay. So the alligator is eating the really big fish. But another way to look at it, this says that the inequality always points to the lesser. So it eats the bigger number or it's pointing towards the smaller number. So the lesser of the two numbers is the number farthest to the left on the number line. So negative 5 is less than 0 because it's farther to the left. So on the number line, 1 is to the left of 4, and we write 1 is less than 4, or we write 4 is greater than 1. On the number line, negative 3 is to the left of negative 1, and we write that negative 3 is less than negative 1, or we write and say negative 1 is greater than negative 3. So if there's an underline underneath it, what does that mean? You guys remember?
No.
Equal to
It
or
means
less
equal
than.
to, right. So this one right here means that the number to its left is less than or equal to the number to its right. This symbol means that the number to its left is more than or equal to the number to its right. Examples. 2 is less than or equal to 3 is true. 2 is less than or equal to 2 is true. 2 is less than or equal to 1 is false. 5 is greater than or equal to 1 is true. 5 is greater than or equal to 5 is true. And 5 is greater than or equal to 6 is false. So, solving inequalities. We've been solving equations. Jack?
How would 5 is greater than or equal to 1 is true? And it's obviously greater.
Right. So saying that it's greater than is true.
Why do you mean
Only
like
one part
or
has to be
equal
true.
to?
Because you have two options. You can say, we say that it's greater than or equal to. So if it falls into either one of those categories, it's
How
true.
is 2 equal to 3?
We're not saying that 2 is equal to 3. We're saying that 2 is less than 3. We're saying that 2 is less than or equal to. You have an or statement in there. Because that's how it's written. So solving inequalities. This is what we're working on today. We're going to have statements with inequality symbols instead of an equal sign. Same process. We're trying to get the variable by itself. Okay? Instead of having an equal sign, we're going to have an inequality sign in there. So 2x less than 4, y minus 5 greater than or equal to 7, and 3x greater than negative 10 plus x are examples of inequalities in one variable. To solve inequalities means to find all replacements of x that make the relationship true. The addition principle states that it is legal to add or subtract any number to or from both sides of any inequality. So this is the same thing as what we've been doing. What we do to one side, we have to do to the other. So let's practice.
No.
It smells good.
All right, so example 1.
It's a barely sprinkle. I learned that. I've seen it, so you must be right. You seen it?
Watch it for like
Saw it.
Because we've never seen snow before, right?
Not this year.
Yes, we have.
We have actually.
I didn't see it.
No, it's just a fact. Weather is distracting.
Yeah. All right, so we have x minus 5 is greater than or equal to negative 7. We want to get the x by itself,
We had 5.
so we add 5 to both sides. The 5's cancel, and our statement becomes x is greater than or equal to -7 plus 5, which is -2.
That could be anything.
You're right. So let's look at what that means on a number line. So we have, here's -3, -2, -1, 0. The solution to this problem is not one number like it's been with the equations, but the solution is several numbers. And what this says is x is greater than or equal to -2. Here's -2. It's greater than -2. So it could be -2, it could be -1, it could be 0, it could be any number that's greater than -2. So that's what the solution means. We're not going to be graphing these, we're just trying to find the solution. Example 2, x plus 4 is less than 6. We want to subtract 4 from both sides. The 4's cancel, and we have x is less than 6 minus 4, which is 2. So if we were to graph this, we have 3, 4, 2, 1. Bless you. The solution to this problem is x is less than 2. So here's 2, and we can choose any number that's less than 2, and it makes this statement true.
We're doing the work at full number line.
No, we're not going to do the number line today.
Okay, good.
All right, the multiplication principle states that it is legal to multiply or divide both sides of an inequality by the same number. So same thing that we did before. What you do to one side, you have to do to the other. If we're undoing multiplication or undoing division, we do it to both sides. However, when multiplying or dividing by a negative number, this is very important, the inequality symbol must flip directions. So what that means is, on example 3, we have -5x is less than 20. We want to get the x by itself, so what do we do to both sides? Divide by -5. The -5's cancel, so we write down x. Now, because we have divided by a negative number, we have to flip the direction of the inequality symbol. So instead of it being less than, it now becomes greater than 20 divided by -5, which is -4. And we're done.
Negative number.
Only if you're multiplying or dividing by a negative number.
Okay.
If you're multiplying or dividing by a positive, you leave it alone. But if you multiply or divide by a negative, then you flip the sign. Example 4. We have 4y is greater than or equal to -8. What are we going to do to both sides? Divide by 4. So we have y. What happens with our symbol? It stays the same. Is greater than or equal to -8 divided by 4, which is -2. And we're done with that one. Example 5. We have -1/3 x plus 5 is greater than or equal to 4.
Would you use the reciprocal on this? Well, first, why don't you subtract 5 from both sides?
So are we going to subtract 5 from both sides first?
Yeah.
Yeah.
Okay. So we have -5 to both sides. So the 5's cancel. So now we have -1/3 x. Bring down your symbol, greater than or equal to 4 minus 5, which gives us -1. Now what do we do to both sides?
Reciprocal.
Multiply by the reciprocal. And the reciprocal is what?
3 over -1.
3 over -1. So The 3's cancel, the 1's cancel, and we have x. And now we flip the sign because we've multiplied by a negative number. X is less than or equal to -1 times 3 divided by -1, which is?
-3.
3.
We have two negatives here, so that makes
Oh,
it
positive, so
positive.
positive.
That was easy. So, this is very similar to what you've been working with, except, yes, you have different signs.